All right, I'm going to get started here. I don't have anyone physically in the classroom, so I'm shutting my doors. There's some background noise. And I've got no one on Zoom yet, so we've finished up to section 3.3, and so I'm going to do some example problems from the textbook. I might, if I don't see anyone come into the chat, do this in small sections. I'm trying to get my Zoom controls in a nice place. All right, I think I have everything I need there. So I'm going to look at some examples out of the textbook for each of the sections we've covered in Chapter 3. There we go. So we'll look at section 3.1 first. All right, so let's look at some of the exercises in the textbook. Specifically, I'm going to look at right now question 7, which says find an equation for a tangent line. To the curve at the point. So I think some key things that if we want to ask, line up with what the equation is asking for, is the tangent line is going to be the results of things. And what our givens are going to be are a point and a curve. And so in question 7, our givens are y equals 2 times the square root of x, and it's going to be at the point 1 comma 2. And the thing we're aiming to get is a tangent line. So whenever you have a point and you want a line through it, you're going to work your way back towards the point slope formula. And if we look at the point slope formula, what we're missing is a slope. And we should be, as we're progressing through this material, recognizing that the derivative lets us find a point, the slope at a point on a curve. For lines, the slope was always is the same everywhere, but for any other curve, as the function progresses, the slope also changes. So the derivative becomes the thing that we want to find. So our derivative formula then, what's going to find slope? Slope is equal to f prime at this given x point. And for us, we can turn that into an equation of f of x at that point plus h minus f of x over h, all in the limit as h goes to 0. And so h is a step size. We're taking a small step on the curve, and we're getting the slope between 2 points separated by a small step in x. And what we hope to do is we make the size of that small enough that we get an instantaneous slope. So let's take our information in here. We're going to say that this m, all said and done, is going to be the limit as h approaches infinity, or 0. The other, the anti-infinity, I guess. Yeah, we'll make 0 anti-infinity. Since I messed up what I was saying, we'll make it useful here. And so f of, and we'll look at our point, our x sub 0 or x sub 1 is 1 plus h minus f of 1 over h as h goes to 0. So my limit becomes 2 times the square root of 1 plus h minus 2 times the square root of 1 over h. Now, whenever we see radicals here, one of our jobs that might be helpful for us is to get the things out of the radical. And because this has a negative sign, we're going to exploit the idea that a squared minus b squared equals a minus b times a plus b. We'll use the difference of a squares formula to work on the conjugate of these radicals. So I'm going to be lazy here. I'm going to take one more step. Both of these have a factor of 2. So I'm going to pull out the factor of 2. In fact, I want to pull out the 2 and h. So I'm just working on 1 plus h square root minus square root of 1 all over 1. I'm going to focus on the thing that's giving me a problem and leave the other stuff out here. And so to clear these, I'm going to multiply by 1, because we always multiply by 1, because that doesn't change the value. But I'm going to use my form of 1 so that I have a conjugate to this radical up here. And so if I have this in the numerator, I need the same thing in the denominator. And because we're focusing on the square root property here, I know that this upper term gives me the difference of squares. So I'm going to have the first term squared minus the second term squared all over that. And we'll notice the 1's cancel, leaving me with h. And this h and this h cancels. So this leaves me with 2 over the square root of 1 plus h plus the square root of 1. And now we can take our limit, because we have, whoops, I wrote a really big square root sign here. Sorry about that. Let me fix that big square root. 1 plus h plus square root of 1. Take the limit as h goes to 0. Because there's nothing stopping h from going to 0 now, we will take the limit, so we substitute 0 in, and I get the square root of 1 plus 1, or the slope is 1. So we found our slope. So we can come back up here, and we can now use our point slope formula to find our tangent line. So we can say that our tangent line, y tangent minus 2, because that's our y sub 1, times 1 times x minus 1. And so we're going to get y equals x plus 1 is our tangent line at that given point.